Finally, let me say a few words on how to do experiments, and we're going to look at examples later on, so don't worry if this sounds too abstract. So typically when you want to run an abstract, you need to have a plan. So basically you need to know what is the question that you want to answer, right? So for example, this could be very simple. So if you want to run an experiment on a sorting algorithm, for example, the question could be, does this algorithm run in an log n time? Okay. And once you figure out what you want to do, you need to design your tests. So you could have test programs and input generators. So these are typically very important. So for example, if you want to test your sorting algorithm, you need to have another program that generates input. This is because you want to test your input on many different input sizes, right? So for example, you want to get this plot where you have the log of the size of the input. So for example, you want to start from 10 to the 10, 10 to the 11, or 2 to the 10, 2 to the 11, etc. input sizes. And to generate each one of these inputs, you need to have a input generator that generates these inputs for you. And once you decide that, you need to know what you want to measure. Again, this number 3, so the question could already easily answer this number 3. But sometimes this could be tricky. If you want to answer a complicated question, it might not be very obvious what is it exactly that I need to measure, but so you need to think about it and argue for it. And once you do all of those things, then you could get to the final category, which is, do I want to have one type of input or different types of inputs, how many different input sizes I want to test, and etc. And once we're done with the planning, we need to execute our plan. So basically you run your experiments, you make a plot, like analyzing could be just make a plot. So you get a plot like this. Another question is, does this make sense? Well, in this case, since if you want to test whether an algorithm runs in log n time or not, you probably need to divide the runtime by n log n. So you take the running time divided by n log n, you plot it, and then maybe it looks like this. And then you say, wait a second, this is not a flat line, so therefore there is something funny happening here, and then potentially you go back to here. And now your question is, why does this plot doesn't show a straight line? Okay, so that gives you new questions, and then you could repeat this whole thing again. So that's basically, in abstract terms, how we can run experiments. You start with a plan, you design your test, you analyze your test, and if there are still questions coming up from this analysis part, you can go back to the beginning. In the course website, there is a paper called How Not to Do It. It's a very short paper. It's like 5 pages long, and they make a lot of valid points. Of course, that paper is about a different category of problems, so not everything in that paper will be relevant, but there are lots of very interesting points made in there. So just to make sure that you take a look at that paper and read it, so that you're prepared for the projects that later on you're going to start working on. So that concludes the initial part of algorithm engineering, where we look at algorithm engineering in abstract terms. In the next videos, I'll start to look at some concrete papers, and we'll try to analyze and understand how those papers are written and what people have done about algorithm engineering.